This is topic 12-4, solving systems of equations by matrices. Our objective today is I can solve systems of equations using matrices. So our essential question is going to be, how can I solve systems of equations using matrices? By the end of this video, you should be able to answer this question. Our bellwork problem, it's a review problem graphing inequalities. And so you are given 2x minus 3y is greater than or equal to -3, and we need to graph. Just like any other equation, we need to get it into slope-intercept form, which means we want to solve it for y. We want to get y by itself. We'll have something times x plus something. I drew my line down the inequality sign. The -3 is already on the other side, so it doesn't change. I drop it down. The 2x is on the left side. We need to move it to the right side. So we're going to subtract 2x from the left, meaning subtract 2x from the right. That tells us the number in front of the x is going to be a -2. Last, the number in the box with the y is a -3. So to get rid of the number in the box, we divide by -3. We're going to divide both sides by -3. Because it is an inequality, and we just divide it by a negative number, that means we must switch the inequality sign, and it will now change to less than or equal to. Now we can simplify. We have y is less than or equal to. The -2 over -3 will become +2/3, followed by an x, plus the -3 divided by -3 is a +1. So we know it's an inequality that's less than or equal to. This tells me we have a solid line and that the shading is below because it's less than. Our slope for this line is 2/3. That's the number in front of the x, and the y-intercept is a +1. So now for us to graph, we started our beginning point, or the y-intercept. It is a +1. On the y-axis, we'll go to +1. Our slope is a +2/3, so that means we're going to go up 2 and to the right 3. From our y-intercept, we go up 2 to the right 3, up 2 to the right 3, up 2 to the right 3. And that's as far as we can go on this graph. So go back to the y-intercept and do the opposite. Down 2 to the left 3. Down 2 to the left 3. That way we can fill in our entire grid. Down 2 to the left 3. We are going to connect our dots with a solid line. And then lastly, this is shaded below. So we're going to shade our graph below this line. Because it's a solid line, that means the solid line itself is also part of the solution. Before going on to our topic for today, here are the answers for assignment 12-3. If you need more time, you need to pause the video in order to check your answers properly. Here are the answers with their particular graphs. Again, pause the video if you need to. So our objective is, how can I solve these using matrices? But the first thing we're going to do is to review how we've solved systems in the past. When we are given systems in standard form, our equations are in standard form, the first thing we have to do is to get them into the y-equal form, or the slope-intercept form. So we'll take our first equation, 2x plus y equals a -8, and we need to change it to y-equal form, or slope-intercept form, meaning y equals blank x plus blank. Goal is to get y by itself, so we're going to put in the box the plus and the number in front of the y. It's an understood one. The -8 is already on the other side, so we just drop it down at the end. +2x, we got to move it to the other side, so we're subtracting 2x from both sides. That means the number in front of the x is a -2. And then we're going to divide by the numbers in the box with the y to get the y by itself. So we're going to divide everything by 1. That leaves us with y equals a negative 2x and then negative 8, because minus 8. Negative 8 divided by 1 is a negative 8, so plus a negative will give us a minus 8. This equation then tells us that our slope is a negative 2. We'll put it over 1 so we can graph it. Negative means down 2 to the right 1. And then our y-intercept is negative 8, so that tells us we're going to start off at the point 0, negative 8. So our first graph will start off at 0, negative 8. That's our beginning point. And then our slope is down 2 to the right 1. I've done the right side, now to do the opposite side. The left side we do the opposite, so we'll go to up 2 and to the left 1. Up 2 to the left 1, up 2 to the left 1. Follow the pattern till we go through the whole grid. And then we will graph our line through those points. This is my first equation. I'm going to label it y1. The second equation, we have x minus 3y equals 3. And we need it in slope-intercept form, so we want to get the y by itself. We'll box in the negative 3 with the y. Draw a line down the equal sign, and then we want y by itself in the end, something in front of x plus something on the end. Looking at our equation, the 3 is already on the opposite side of the y, so it just drops down. We have an x on the left side with our negative 3y. It's our 1 in front of it, so we move it to the other side by subtracting 1x from both sides. That tells us the number in front of the x is a negative 1. And then last, to get rid of the number with the y, we have to divide by negative 3, so we're going to divide the right side by negative 3. This will give us y equals a negative 1 over negative 3 is a positive 1/3, and then 3 divided by negative 3 is a negative 1. So positive 1/3 minus 1. This tells us that the slope is a positive 1/3, and our y-intercept is negative 1, or the coordinate 0, negative 1. So graphing, we have to start off at 0, negative 1. Use our slope, it's positive, that's up 1 and to the right 3. So from the y-intercept, we're going up 1 to the right 3, up 1 to the right 3, up 1 to the right 3, following the pattern. I need the left-hand side, so we do the opposite, down 1 to the left 3. We found our point that they overlap, but let's continue. Down 1 to the left 3, down 1 to the left 3. We can connect our dots. This is the equation for our second y value. And we see that our point where they intersect, I go 1, 2, 3 to the left on the x-axis, so that's negative 3, and then down 2 on the y, so it's a negative 2. And our solution is negative 3 over 2. This was one method in order to graph and solve. The other method we could have used would have been to put this into the calculator and let the calculator solve it for us. So in the calculator, we have our first equation. y1 is negative 2x minus 8. And then our second equation is a positive 1/3 x minus 1. So let's show it on the calculator. The good news is you can choose which version you prefer. And so I showed by hand, and now I'm going to show on the calculator. You do not have to do both. You choose one or the other, whichever one is now your favorite one. So negative 2x minus 8 is our first equation. Our second equation is a 1/3 x and then minus 1. Using the calculator, we do second trace. Choose number 5 because I want to find their intersection. We will now see the graph, and it does look similar to what I have graphed over here. So this is another way that you can check yourself. And then we press enter 3 times. It's our first curve, yes. Second curve, yes. Yes, yes. And now our intersection is at negative 3, negative 2, which is the solution that we got. It is the point that is on both of the lines and therefore solution. So today, what our objective is saying, I can solve systems of equations using matrices. First thing we have to figure out is what is a matrix. One of the reasons that we use matrices is because when we're given equations in standard form, first we have to solve them for y before we can graph them either on the calculator or even on the grid. So this is one extra step, which means that's a step that I could possibly make a mistake. So when we're using matrices, it is a way in which we can solve these systems and I do not have to solve for y. So let's find out what is a matrix. A matrix is a rectangular arrangement of numbers in rows and columns. The number of rows go horizontal and the number of columns go vertical. They determine the dimensions of the matrix. If you think about going to a movie theater, you sit in a row. It goes left to right. And then when you look at a building that has columns out front, they go up and down. That's the vertical. The dimensions of a matrix is always written as rows by columns. When you see that little X, we say the word by. And it's kind of like when you go to Lowe's or Home Depot and get a piece of wood, you tell them you want a 2x4. You don't tell them you want an 8. You want a 2x4 because the 2 represents your width and the 4 represents your length. Same thing is going on with a matrix. We're going to give it the rows, then the columns. So I'm giving you an example. It's rectangular, so we're going to open up a rectangle, and then we're going to put some numbers in. So I'm going to do 1, 2, 3, 4. Here's a row, and then do 5, 6, 7, 8. Got another row, and let's close off the rectangle. This is a great example of a matrix. What you will see is we have 2 rows. The first row contains 1, 2, 3, 4. The second row contains 5, 6, 7, 8. So when I go to write my dimensions, I know I have 2 rows because I start with my rows. Then I say by. Now I'm looking at my columns. Column 1, here's another column with 2 and 6, another column with 3 and 7, and a last column with 4 and 8. So notice how those numbers line up. So in this case, I have 4 columns. That means my dimensions are a 2x4. We just created a 2x4 matrix. Now you get to try. We're going to determine the dimensions of these matrices. So on the first one is A. You can start off by labeling your rows. Remember, they go up and down, or side to side, like you're in a movie theater. So we say that there are 3 rows. Then we'll look at our columns. There are 2 columns. So our dimensions are 3 by 2. This is a 3 by 2 matrix. You might notice me using matrices and matrix. Matrix is when I talk about one. Matrices is the plural. So letter B. Again, we're going to figure out how many rows. And some of you might get to the point you do not need to circle. And then look at the columns. So B is a 2 by 3 matrix. Make sure you put the little X in between so we know that we're talking about a dimension. And the last one, our rows go left or right. There's 2 of them. And our columns up and down, there's 2 of them. So this is a 2 by 2 matrix. Most of the matrices that we are going to be dealing with are 2 by 2s. So next, let's look at how are we going to use these matrices. So before we use the matrices, we're going to review how have we solved equations in the past, and then use that method in order to help us to solve a matrix. So the first thing we see is 2x equals 14. And in the past, with 2x equals 14, if I want x by itself, I would divide both sides by 2. And that would leave us with x is 14 divided by 2 is 7. We're going to use this same method. Our matrix is going to be an unknown, and I want to solve for the unknown. Unfortunately, in your calculator, it will not divide matrices. So we have to come up with another way that we can do this problem without dividing. Apologize for that. So let's look at what is another way that we can do this problem without dividing. Starting off with 2x equals 14. Well, before I divide it by 2, now what if I multiply both sides by 1/2? So instead of dividing by 2, I'm multiplying both sides by 1/2. If I use my calculator, I can see this should give me the same answer. If I multiply 1/2 times 2, I should get a 1, and I'm left with x. If I multiply 1/2 times 14, again, I should get 7. Let's see. 1 divided by 2 times 14, and sure enough, it gives me 7. So I have it to where, okay, I can multiply and be able to get my answer. The unfortunate part again is when I'm multiplying, I'm having something in a denominator, which again the calculator sees as division. So one more thing. Another way that we can write this 1/2 without having to put it in a fraction form is to write it as 2 to the negative 1 power. If I look on my calculator, you will see that I have an x to the negative 1 button right below the math. So we're going to type in 2 and raise it to the negative 1 power. So you type in your number first, then you push that button, and you now see I have 2 raised to the negative 1 power. When I press enter, you will see that equals 0.5. So instead of dividing by 2 or multiplying by 1/2, we are now going to multiply 14 by the 2 to the negative 1 power. Because we've just shown that 2 to the negative 1 power is 1/2. I show it multiplied by 14, and sure enough, that gives us our answer 7. This last way that we did it, this is the way that's going to help us on the calculator. We're just, instead of, again, dividing by 2 or multiplying by 1/2, because we're using matrices, we're going to be able to take something and raise it to the negative 1 power in order to be able to get to the same answer. So let's talk about how this is going to be used. You will see what are the steps to enter a matrix on your calculator listed above. So the first thing says is we want to make sure your equations are in standard form. That means you have an AX, you have some number times X plus some number times Y equal to C. Let's look at our second problem. I have 2x plus y equals negative 8 and x minus 3y equals 3. Yes, so we are in good shape. So now we're going to press the second button and x to the negative 1, and you will see that will bring us to the matrix button. So right above the x to the negative 1, you see the matrix. I'm going to hold off on that for just a moment, because first we have to figure out what are we going to type into the calculator before we get to the calculator part. So let's look at this problem. First thing we want to do is set it up in matrix form. So we're going to set up our matrices, and then we'll know what to type into the calculator. Our first matrix, A, is going to come from the coefficients of your x's and your y's. So I'm going to go over to 2 and say, hey, matrix A is going to come from the coefficients of my x's and my y's. And the first row is going to represent my first equation. The second row should represent the second equation. So the number in front of x is 2. That goes in my first blank. The number in front of y is 1. In the second equation, the number in front of x is an understood 1. Again, if there's not something shown, we know it's a 1. And the number in front of y is a negative 3. So we know that first column represents my x's, the coefficients, and the second column represents the coefficients to the y. My second matrix, we call that matrix A. The second matrix we call matrix X. X in our equations have always represented an unknown. If we go back to the equation we solved up above, the 2x equals 14, the x represents the unknown number we're trying to solve. So in this case, our matrix X is going to represent the letters that we're trying to solve. We have 2 letters. We have an X and a Y. So we're going to write our letters are X and Y. I'm trying to figure out what those are. And then last, our matrix B is going to be, well, what are these things equal to? And what we have that they're equal to is a -8, and a -3. They are on the other side of the equal sign. So in a sense, our matrices are very much similar to the equations that we have. We have our coefficients, we have our letters that we're trying to find, and then we have what they're equal to. And that should be a +3, not a -3. Apologize for that. So now we're going to solve, and the way that we're going to solve is using what we've just learned from the equation above. So the way that we're going to use the process from above is, notice we are trying to get our matrix X by itself. So we can think of this as, I have some number A, or some number represented by A, and then I have my X, which is my unknown, and then it is equal to my B. If I follow what I did earlier, instead of dividing or multiplying, to get my X by itself, we are going to say A raised to the -1, which is also known as the inverse, and then we're going to multiply that times B. So this little equation here is what we're going to use in order to help us. And what you see is that equation is already written there. It's saying I'm going to take my matrix that is an X, this is my XY, my unknowns, I have now isolated them, and now to solve what they are, I'm going to type in A to the -1. So my matrix is A is 2, 1, 1, -3, and then we multiply it times B. It is very important that you always put the matrix that you're bringing to the -1 power up front. Otherwise, it will not work. So before we put things into the matrix, we're going to follow these steps. So we have our equations, and we have now written our matrices. And what I have at the bottom here is the minimum amount of work for you to show when you are doing your work on your homework and on a test. This is showing me what you type into your calculator. So let's follow our steps now. We are going to press the second, and then let me turn my calculator on. We're going to press the second and then the X to the -1 button in order to get to matrix. If you look at the X to the -1, right above it in blue says matrix. So when I hit second and then I hit that button, it's saying I want to go to the matrix. Now we're going to scroll over to edit. It's kind of like stat. We have to put in our information before we can use it. So edit means I'm going to input that information. I'm going to choose number 1 for matrix A and then choose 2 for matrix B. So let's start with matrix A. Number 1 is matrix A. Notice the first thing it asks you is the dimensions. So let's look at matrix A and see what my dimensions are. I have 2 rows and 2 columns. So dimensions go by rows first. So 2, we press enter, and then 2 will give us the columns. And now you will see you have 4 spots that you can put information in. We're going to copy in the numbers just like you see in your matrix. Our top left number is a 2. When I press enter, it goes on the same row but the next column. So it's a 1. So we're putting in our coefficients for our X and our Y for our first equation. You have to press enter after you enter a number. So now I'm on my second equation. X coordinate is 1, Y coordinate is -3. If you don't press enter, notice that this number has not changed. So you must press enter. Hence step 4 says to press enter. I'm sorry. Step 4, we chose the matrix. Step 5, we typed in the dimensions. We pressed enter. And then step 6 is type in the number in the matrices, pressing enter after each entry. So pressing enter after our last one, we now see I do have a -3 in there. Now to get to my matrix B, I'm going to follow these same steps. So I hit second, X to the -1. Notice now it shows me, hey, in matrix A, I have a 2 by 2 matrix. Now I want to put in B. So I got edit, and this time we're choosing number 2 to input matrix B. Matrix B, I will count, it has 2 rows and 1 column. So this dimension is going to be a 2 by 1. Pressing enter after each number you press in there. Now we can type the numbers into the matrix. Our first number is -8. Press enter. Second number is 3. Press enter. And I will look, and I do have a -8 and a 3 in there. To exit out of matrix, we hit the second and then mode, because right above mode says quit. Now that we have our matrices in there, now we actually want to, in a sense, type in this equation that I wrote down. We want our unknowns to be matrix A raised to the -1 power times matrix B. So the way that we do that is we hit the second matrix, or second -1 again, and now we're just going to choose which matrix we want to deal with. So we want matrix A first. Notice I have the matrix A, but now I want to raise it to the -1 power, so this time I'm just going to hit the x to the -1. And now I want matrix B. So again, I have to hit second and then x to the -1, and now I'm going to choose 2 to get my matrix B. We now have an A to the -1 times B, which is very similar to what I said. In order to get our unknowns, we have to write in that form. Now we press enter, and you will now see one matrix comes up, and it is -3, -2. There's no line with it. So -3, -2, this corresponds to our unknown. So that means our top number is our x, that's a -3, our bottom number is a -2, and we write it as an ordered pair. We have now determined the point that is in both of those lines. So I'm going to stop this recording right now because it's rather long, and then I'll do part 2 in the next recording. That will do the last 2 problems that are on your notes.